Hello, I'm David Johnson, and today Premier System Integrators in the Foxboro Southeastern IA User Group is pleased to present a presentation on high-level batch language best practices. If you want to reach me after this presentation, I can be reached at my email, david.johnson@premier-system.com. I'd be happy to discuss anything that you find in this presentation you'd like to talk about. The reason we're doing HLBL best practices is because there's so many bad examples of code out there in the Foxboro world that I thought it would be a good idea to start finding ways that we could do a better job, share that knowledge, and get it out into the rest of the population. So what is HLBL? It stands for High-Level Batch Language. It's also known as sequence code. Some of the PLC guys would refer to it as structured text. It looks a lot like that for them. And Foxboro has a Pascal derivative, and it gets compiled into byte code. We'll talk a little bit more about that as we go. It's interpreted by the control processor. It can be used standalone. It's used as part of their batch system, the S88 batching system, like in batch. It's also part of the Foxboro sequential function chart package, the SFC package. Today we're going to focus on the IND, the independent sequence block. The documentation, if you're working with these, that is relevant is B0400DF Rev R, B0193AX, the standard block books that's in volume 2, and the B0193AW Rev T. I think there may be a newer version of this somewhere, but it's the integrated control software concepts. And after talking to Marcel, there is a document on operational recommendations that explains some of the differences with the C preprocessor that they've gone to. We'll discuss that as we go. The three files we're going to discuss today are the .s file, that's the source file for your sequence code, the R file, or the reference file from the compiled code, and the .i file. It's a byte compiled code that gets interpreted by the control processor. The first thing we'll talk about is the .s file, the source, probably the most important part of all this. When you're using the integrated control configurator, the old ICC, you're going to find that in opfox, CIO, CFG, and then it'll be whatever the name of the compound is, and then you have the name of the block. One of the most helpful things you can do to produce better sequence code is to use an editor that gives you syntax highlighting. Some examples of that are UltraEdit and Notepad++. Those are two that we use here in the office a lot. We've run into one gentleman that used Sublime, and we were able to put together a syntax highlight file for that editor. And then the FCS Evo editor has syntax highlighting built in. There's a lot of things about that editor that I'm not crazy about, but at least they've got syntax highlighting now. So let's look at some of the advantages of going with a syntax highlighting editor. What I'm looking at right now is UltraEdit. UltraEdit is, and this is the original independent sequence block. When you start one, you're going to get a empty file like this. We'll talk about that in just a minute, but one of the nice things is, as you can see, my reserved words here, I've chosen to put those in a deep blue. The comments are in more of a teal color behind that. And one of the things you might notice about UltraEdit that's nice is these brackets over here. And I'm able to collapse that code in these comments without having to lose any of that. It shows me that I've got collapsed stuff out there. And so as you can see, this is the structure that really matters to start with a sequence block. So independent sequence, constants, variables, user labels, statements, and then the end of the sequence. So it's just nice to have an editor that allows us this kind of flexibility. Now, one of the nice things about this is the other day, I had a engineer out at a job site, and he was having trouble compiling some code, and he sent it back to us, and he said, "What's the problem with this?" And so as we looked at it, we quickly threw it into one of our editors, and it became readily apparent that he was missing the end of a comment which is so obvious to see when you have something like this versus trying to find that same problem in an editor that doesn't provide that highlighting. So it's a lot easier for us to work inside one of these when you can look at it that way. Next thing we'll look at is the .r file. The .r file is the reference file. When you're using the control configurator and you compile your block, it's going to provide this, and it will put that inside of select and show what's going on for troubleshooting. The file is binary, but the Unix strings command will generate usable text for things that we might want to do with it. And so that's very handy to have too. So let's take a look at that. We'll go to our virtual machine. And here you see, if we go into this code with examples, you're going to find that we have several pieces of sequence code in here. And one of these that we're going to look at, we can look at, let's do the define.s. So if we try to look at the R file on that, you can see it's not a text file. So not very helpful. But if we were to provide the Unix strings command, it generates the same code that we would find when we go into select and look at this. So if we were to go into Fox Select, and look at the code, if we look at this versus this, you'll find that we've got the same exact code. This is useful for taking this out, putting it in an editor, documenting your code some way. It gives us a good way to get to these reference files without having to go through the compiler or other things like that, snatch it out of there. So that's something that's handy to know. It's useful when we're wanting to do this. The next part of this is going to be what happens with the .i file. So we'll go back out. The .i file is the file that's pushed into the CP. It's where the processing actually happens. And so there's a lot about that we can discuss, but one of the things is the .i file does not actually contain all of the code that you write as source code. The interpreter actually is working on byte compiled code. So what it does is it compiles this down so that your logical names, your variable names, your user labels, things like that are put into a table, and it's using its own internal variables to store those. So what that allows it to do is it doesn't really matter how long a name we use. It's not going to take up any more space, and you'll find that some of that stuff is helpful later. One of the things that we have done is the sequence skeleton file, which is brought in when you initially go to edit a block. We're going to find that that file is no longer valid. It was set up for CP10s a long time ago, and so now if we go to an original independent sequence block, you're going to find it says 10 character names. It's going to tell us that our subroutine names, things like this. So the first thing that we've done to help improve sequence code is we have written a new independent block.s. We've put this up on the website, and what it does is it tells you that the 16 character names, where they've gone from 10 to 16, it does a little better job telling you that, you know, the subroutine has a 10 character name, 16 character argument names, and things like that. So this was done just to, all it does is just let you know what you're looking at. So we put that out as template 1. We can put other things into this as we go. We've had a few discussions about putting some exception handling into this, but for the moment we're going to put this up there. You can replace the ind block.s in your sequence skeleton folder, and then it'll bring this in and you can go from there. This works very well, and has been good. It's just changes in comments, but it makes it a lot easier for you to know what you're working with. Okay. The next thing that I'd like to talk about is the compiler items. Now, one of the things people have been concerned with when they do sequence code is they come in and they say things like, I don't want to put a lot of comments in them. They take up too much space. I'm worried about the processor. I'm worried about, overloading things. What we've found is that if you look at the various types of comments, okay, the .I file, the actual interpreted file that's going to get loaded, or the compiled file that's going to be loaded into the controller. If you put a comment in, those comments do not go into the controller. Even the operator comments, when you have a parenthesis and an asterisk like this, those comments will get dragged into the .R file, but they do not go into the .I file. So no matter what kind of comment you put on here, you're not costing yourself anything from a control processor standpoint. It's just taking up a little more space in the on the disk. So here's our original size of the .I afterwards, and you can see that putting in comments gave us no additional size. Another thing that's interesting to note is that if you add a variable, whether it's a 3-character variable name or a 16-character variable name, which is the limit of valid variable names, or a 20-character variable name, which, by the way, it will take and will not give you an error, but it will not look at the characters after the 16th character. What you'll find is that it will compress those down when it compiles, and the cost of a variable name is apparently 6 bytes in the interpreted file, regardless of how long a variable name you need or you use. So using a variable name like X or R or something really short in an effort to save memory is not really saving you any memory. So use a meaningful variable name. The same thing, even more interesting, is on user labels. Well, user labels, as far as I can tell, are variable names that have already been assigned. They've assigned that name, they call it a user label, and you can redefine a user label, but no matter what you do to a user label, there is no additional size in the control processor. Once you get to an interpreted file that is running, it doesn't add anything. So there is an advantage to renaming those user labels and using a more meaningful variable name. Another thing that we have found, obviously if you use the same variable name more than once, you'll get an error, or the same user label more than once, you'll get an error. And this is as we would expect. The other part, though, is if you come in here with a block, and here we have named one that goes out past 16 characters, it's longer than 16, it will compile and run successfully with no problems. But if you put a second variable name in that comes out here, and even if they are different, if they're different after the 16th character, it doesn't matter. It chops it off at 16. And so it is not going, it will say that this is an error. You've already declared that variable name, even though the names are different. Sometimes you might inadvertently get to a point where you do that, and you can find that that's a way to tell. You'll say, oh, I've got the same variable name, but you don't. And it's a good way to notice that. It's a bad practice probably to name them longer than 16 characters, but it will work. So now we're going to discuss some of the differences with the C preprocessor. Now there are different versions of the C preprocessor, and this gives you a potential problem going forward. The original C preprocessor was changed or has been modified during IA somewhere along the lines of like 8.4.2. There is a section in the operational recommendations, section 10.6, which explains the differences in the preprocessor. This is worth reading because you want to make sure that you don't have an issue as you go forward with your old HLBL code, and that the preprocessor will generate the same code when you're done. In Evo, you have the option of telling it to use the old style preprocessor or the new style. But if you use the new style, you've got to make all of your old code come up to the correct. It has to compile correctly using the new style C preprocessor. If you set it to use the old style, you're fine unless it ever gets changed to the new style, in which case you would have to recompile and revalidate all of your sequence code. So we had a discussion on that when people were calling in. So that being said, let's take a look at some of this. Okay. Here you see we've got a little piece of sequence code. It's written, and we have some constants. We have the maximum number of pumps set to 10. We have start set to true, a wait time, and then we're coming down through here, and it's turning on the pumps in Boolean array 1. So it's going to go through there, and it's just going to turn all of those on. Now, you can see that when we have this piece of code, looks exactly like this piece of code. But the difference is here we've used pound defines. Pound define the maximum number of pumps, 10, start true. If you look at these two pieces of code back and forth together, you'll see that the only thing that's different is the constants versus the pound defines. And the rest of the code is identical down here. However, when we take these and we generate the .r files, which we've done, you'll find that here, where we have the maximum pumps and the start and the wait time, if you look at how it looks when we do a constant, you will see for index equals 1 to max pumps, start time, wait time. However, if we do a pound define to generate the same thing, we get the value that was defined, but we don't get the variable names. So we don't know if this is meaningful to you. You lose that by using the pound defines. There's no significant advantage to that. It doesn't take up some of the space, I suppose, but to hold a variable or whatever a constant is treated like inside the controls, but it does not retain the name that you had here. It's going to just take whatever's on the other side of this and put it in. It does this before it goes through the compile process, so the preprocessor will run through, make those substitutions, and then the compiler will take it, and then you will get the code out of it. One of the things that can do is when we have code like this was done just for this purpose, where we have open equals true, failed to open valve, and then we come over here and it looks identical. This is the source code. Once again, here we have a constant, and here we have the pound define. But what you'll find is, when we're going to show, is that when you pound define this, it does not care that this is in quotes down here. And so even though your source code says failed to open valve 122, if we go and look at this in our control processor, toggle this to auto, and look at our string. Well, that ran fast, but it's only one line. It says failed to open valve 122. But if we were to do the same thing using our pound define code, there we go, it ran. And we look at our strings, failed to true valve 122. So even though the sequence code is identical, as we can see here, we get different results after it's gone through the preprocessor. So that's a reason to be aware of that. The other thing is the include files. If you do a pound include, the preprocessor goes out, takes that file, it inserts all of the text from the file into the source code that you're working with, and then compiles it. Include files are useful if you have a lot of instances where you want to do exactly the same thing, but the key word there is exactly. If you ever have an instance where you want to change it for something, and you go modify the include file to make things work like you want and compile it, and it compiles successfully, you need to go find everywhere that include file has been used by any other piece of code which is still running, and you have to recompile it, because you could conceivably break something and not know it for a very long time until you go back and recompile and download the code from a different block that was using the same include file. So include files are good if they're used properly, but they're very dangerous, and you have to be very disciplined in how you use them. It's not something that you need to take on lightly. I believe that is all that I'm going to cover today. I hope you'll join me next month. This is the second Tuesday of each month at 11 Central Time. We will be conducting another topic, and we will continue to work on this, and hopefully you can call in and join us for that, and I appreciate your time. Thank you.